Hello viewers, today we are going to start a series on metamorphic petrology. In this series, I will cover the type of metamorphism. If suppose we divide on the basis of local and regional scales, then on that basis we can divide the metamorphism into two types. One is your local metamorphism and other is your regional metamorphism. Particularly in local metamorphism, that must be in local scale, and in regional, that occupy 1,000 of square kilometers. If suppose we will see the local metamorphism, 2-3 processes are important here, particularly the cataclastic metamorphism or dynamic metamorphism, as well as the thermal metamorphism. Particularly, if suppose we will see, and on the basis of factor responsible for the metamorphism, we can divide the metamorphism into 3 important types. One is your thermal metamorphism, in which the heat is an important factor. Another is your dynamic metamorphism, in which pressure is an important factor. And third is your dynamo-thermal metamorphism, in which the pressure and temperature both are important factors. Now just take the first factors, that is your thermal metamorphism. Particularly in this factor, temperature is an important factor during change of any rock. Now let us see any intrusive body, if intruded in a country rocks, then normally around the intrusive rocks there must be some sort of areoles or zones developed. And from intrusive body towards outer zones, the heat energy is transmitted, and normally if suppose we will move from intrusive body towards the outer zones or areoles, the temperature normally decrease. And mineralogical changes right from immediate contact up to outer part. So normally in thermal metamorphism, heat is an important factor and pressure is very low. And if suppose we see the different metamorphic phases, so particularly during thermal metamorphism, 4 important phases are formed. These are albite epidote Hornfels phases, hornblende Hornfels phases, pyroxene Hornfels phases, and cyanidinite phases. Particularly, cyanidinite phases normally occur at the immediate vicinity of intrusive rocks, and albite epidote Hornfels phases normally occur at the outer fringe. Now let us take the second important factors, that is your dynamic metamorphism. Particularly in dynamic metamorphism, pressure is an important factor. Now let us see what are the changes when the pressure is only important factors or pressure only act on a rock mass. There is 2-3 important things. One is your cataclastic metamorphism or dynamic metamorphism, and second is your burial metamorphism. Now let us see the burial metamorphism. Particularly if suppose we will see the geosynclinal basins. Say for example, if depth is your 25,000 to up to 30,000 feet, so normally the stress pressure is very high, or in other words we can say the load pressure is very high, and normally there are no directional pressure. That is why particularly in dynamic metamorphism, normally there is no structural change. Only new sort of minerals form particularly in geolite phases. If suppose these two factors are important when only the dynamic metamorphism is there. One case is your burial, another is your cataclastic. If suppose we'll see and take the third important things where the pressure as well as temperature both are important, and this metamorphism is known as dynamothermal metamorphism. Here normally pressure as well as directional pressure as well as temperature both are acting. And normally in orogenic belts, the regional metamorphic rocks are formed where we can see the structural changes like slate change into phyllite, phyllite change into schist, and later on schist change into gneiss. We can see how the structural change as well as mineralogical change in case of peltic rocks or in basic rocks or even in ultra basic rocks. If suppose we'll see the basic rocks, normally we can see there are mineralogical change, how the low pressure phases as well as high pressure phases are formed. Geological setting is a quite commonly used as a classification scheme because the geological context is often quite apparent and there is a genetic relationship between the metamorphic type and the agent of metamorphism. These are four general categories: contact, shock, cataclastic, and regional metamorphism. If suppose on the basis of geological setting, if you will take the contact metamorphism, now let us see how the contact metamorphism occur and what are the changes particularly during contact metamorphism. If suppose we'll classify on the basis of local and regional, we know already the local metamorphism, it means is normally occur on a local scales. So we can put the contact metamorphism under local metamorphism also. Particularly in contact metamorphism, there must be an intrusive body. Now let us see the three important cases. If suppose the intrusive body is a granite or syenite or gabbro. Three important igneous rocks with a different temperatures. In a case of granite, normally temperature varies from 650 degrees centigrade up to nearly 800 degrees centigrade. In case of syenite rock, it's normally very around 900 degrees centigrade. In case of gabbroic rock, it's occur nearly 1200 degrees centigrade. Now let us see the case particularly in contact metamorphism. If suppose intrusive body is a three different types, so we can see how the temperature change particularly in country rocks. Now look at on the screen and see the sketches particularly for the contact metamorphism. In case of granitic rock, we can see the thermal areoles will be narrow as compared to gabbroic rocks where the temperature is nearly 1200 degrees centigrade. So these are the important factors, particularly how the thermal areoles or zones are developed. Now look at on the screen and see the width of the intrusive body. Say for example, nearly 0.5 kilometer, 1 kilometer, 1.5 kilometers. If these are the variations particularly in intrusive bodies, what will be the effect particularly on metamorphism of thermal category? Suppose we'll see the third case, particularly at what depth the intrusive body. Normally, we can assume because the geothermal gradient is always vary. In case of continent, is normally vary with 25 degrees centigrade per kilometer to 35 degrees centigrade per kilometer. In this case, the horn-felsic textures are formed, particularly the grains are recrystallize, melt and recrystallize, and normally there is a lack of cystosity. As compared to regional metamorphism and thermal metamorphism or contact metamorphism, there is a lack in cystosity as well as grain size. Particularly in contact metamorphism, grains are finer and recrystallize without any orientations. And normally the shock metamorphism occur due to the impact of meteorites, and particularly in meteorites impact, the high pressure effect, and normally cosites are formed. And if anywhere the cosite is there, we can say this must be a high pressure metamorphism, normally due to impact of meteorites. Now see, let us the another type of metamorphism, that is your regional metamorphism. And particularly, if suppose we will see the regional metamorphism, in regional metamorphism, three categories important. One is your dynamic metamorphism and dynamo-thermal metamorphism, and third case is your ocean ridge metamorphism. If suppose we will see the dynamic metamorphism, particularly in dynamic metamorphism, the cataclastic textures, cataclastic metamorphism occur, and these indicates the shear plains or fault plains. Normally, during cataclastic metamorphism, the rock are crushed and recrystallized. So we can see the fabric change right from outer part towards the shear plains. Close to shear plains, normally the myelonites form where the fabric is almost crushed and fracture develops, which also responsible to percolate the waters. And normally these are the weak plains where, if suppose we'll see the case of Himalayan, normally the landslides occur along these zones. If suppose we'll see the second important case is your burial metamorphism, where the pressure is important factors. And normally in this case, there is no structural change, only due to high load pressures. Normally, the new set of minerals form without any structural deformations. And very important case is your geolite as well as glaucophyll lawsonite phases, where in those two cases, pressure is very high, more than 4 kilobar up to 8 kilobar. And we can see the important sedimentary minerals also occur in these phases. And third important factor, particularly for metamorphism, is in regional, that is your dynamo-thermal metamorphism. As we already discussed, if suppose we'll see the case of ocean ridge metamorphism, prior to 60s and 70s, it was presumed that ocean floor is normally ultramafic or basic igneous rocks. But after the deep sea drilling, Mayashiro, he reported the metamorphic rocks of basic composition along the ridges, particularly where always the thermal imprints is there. Whatever basic rocks or ultra basic rocks is changed into metamorphic rocks. These metamorphic rocks are normally greenstone or amphibolites and equivalent to your oceanic basalts. Now let us see the last type of classification based on plate tectonic and see how the different metamorphic phases occur with different metamorphic plates like plate interior, divergent plate margin, transfer plate margin, and convergent plate margins, and see the important phases occur on 4 different plate margins. Now it's time to conclude particularly the metamorphism and metamorphic classification based on different factors responsible. Now it's time to say goodbye to all of you. Thank you very much.